we're considering uniform circular motion. Means that this object is going around this circle of radius r, and it has a constant speed. That makes it uniform circular motion. Uniform speed means that at equal amount of time, it goes equal amount around the circle. Means that if we define angular speed, omega, this is the Greek letter omega, we use it for angular velocity or angular speed, which is change of this theta angle over time. And we want this to be constant. If the omega is constant, then theta becomes just omega times t. If we start time from theta equal to 0, theta at any other moment will be omega times t. Right? And unit of omega is radians per second. Remember that. Theta is omega t. But how can I write this radial vector, which is position vector of this point, in terms of theta? If the length of this vector is r and angle theta, what are the x and y components? We already know that, right? What are the components of r? If you take r as x I hat plus y j hat, what is x? R times cosine theta, right? And y is r sine theta. And theta is omega t, right? Theta changes by time uniformly. That's why we call it uniform circular motion. And x as a function of time is equal to r, this is constant, times cosine of omega t. And y as a function of time is r, which is constant, times sine omega t. So this x and y, so it changes, like goes back and forth this way, y goes back and forth that way as the object is moving around the circle. Of course, if you want to write the r vector in terms of time explicitly, becomes x times I hat, this is r cosine omega t I hat, plus r sine omega t j hat. Right? Does it make sense so far? Right. Now this is r as a function of time. If I want to find velocity, what should I do? Take derivative, right? Velocity, by definition, is equal to, velocity as a function of time is equal to d over dt of r as a function of time. And just derivative of this expression.
Can you explain the top two in that column again? Like, it's cosine of just omega or cosine?
No, this is omega t in parentheses. Because this theta is omega t, right?
Okay, that is.
T is inside the argument of the sine and cosine. All right. Can you tell me what the derivative of this is? I want to make you remember all those calculus things that you learned.
I think it's going to be negative r omega sine of omega t I hat plus r omega cosine omega t.
That's very good, yes. You're using chain rule, right? Taking this as a new variable, then take the derivative with respect to that variable times the derivative of that variable, which brings you an omega. Right? So using chain rule, v as a function of t is equal to negative, as we said, negative r omega sine omega t I hat plus r omega cosine omega t j hat. This is velocity as a function of time. What is the speed now?
Square root of the I component and j component.
Yes,
squared.
speed is the magnitude of this velocity. Let's calculate the speed. We call it v as the magnitude of velocity is square root of dx squared plus dy squared. And dx is negative r omega sine omega t and dy is r omega cosine omega t. So if you square them, square root of, we get negative, becomes positive, we get r squared, omega squared, sine squared, omega t, plus, what is this? R squared, omega squared, cosine squared of omega.
R omega.
Yes. If you factor r squared omega squared, you get sine squared plus cosine squared, which is 1. So this becomes the only square root of r squared omega squared, which is r omega. This is always the case if something is rotating. The speed of the object that's going around circle is r times the angular speed. We're going to talk about that later on also in rotation. All right. Which direction is this velocity? One thing we can do is we can calculate r dot v. This is reviewing everything that we had. What is dot product of r and v? This is our r, changes with time. This is v, changes with time. What is r dot v? This times that is negative r squared omega sine omega t cosine omega t, right? And if you do this, you get r times r omega, r squared omega plus r squared omega sine omega t cosine omega t, right? What is the result? The two terms? 0. You see the identical terms, one positive, one negative. It gives you identically 0. Means that r dot v is 0 at all time. Means whichever direction is r, v is perpendicular to that. And perpendicular to the radial direction is a tangent to the circle, right? In a circle, tangent to the circle is perpendicular to the radial direction. All right. So far, so good. All right. Now, I want to calculate acceleration. What is acceleration?
Derivative of velocity.
Acceleration vector is derivative of velocity vector as a function of time. So what is the derivative of this? The derivative of velocity.
Negative r omega squared sine or cosine. Omega t.
Negative. What about this?
Negative r omega squared sine.
Negative
omega t.
r omega squared. What is magnitude of acceleration?
Again, square roots and stuff.
Yeah, you say square root of r omega squared cosine squared r squared omega to the 4th sine squared, right? And then sine squared cosine squared gives you 1. Get square root of r squared omega to the 4th or r omega squared. So, right? Without writing this, I guess you can see that acceleration magnitude is r omega squared. Right? And because omega and v are also related, instead of omega we can write v over r. Right? If you write v over r, you get r times v over r squared, which is v squared over r, right? That is the magnitude of the acceleration. I don't know if you remember from high school, or magnitude of the acceleration for uniform circular motion is v squared over r. Or you can write it as r omega squared in terms of omega. Which direction is the acceleration? One way you can do that is if you factor negative omega squared, it becomes times r cosine omega t I hat plus r sine omega t j hat. And that is in the direction of r, right? Multiplied by negative number.
Oh, it's just going to be the opposite. It'll be
Opposite of r, yes. R is this way, A will be exact opposite direction. So that's why we call it centripetal acceleration. So A is negative omega squared times r. It's because it is exactly in the negative direction of r, means that it's toward the center. Because r is directly away from the center, A will be toward the center, and that's why we call it centripetal acceleration. acceleration, it has this magnitude and is toward the center for uniform circular motion. As long as something's going around circle at constant speed, there is this acceleration, always toward the center.